In this video, we will be talking about graphing techniques, specifically horizontal stretching and shrinking. When you're wishing to graph a function y equals f of a times x, where your constant a is multiplied inside the function, then you need to go by the rule that if a point xy lies on the graph of y equal f of x, then the point x divided by a, y, lies on the graph of y equals f of a times x. Now basically this is saying that we're not going to treat this like we normally do. If we have a constant multiplied inside the function, then we have to divide every x value by a, or multiply x value by the reciprocal. Because we know that dividing by a is the same as multiplying by the reciprocal. So let's apply this rule and see how it works. Our first example, we're asked to graph y equals the absolute value of 1/2 x. Our basic graph is y equals absolute value of x. And let me go ahead and draw that in here. Remember, it's the one that looks like a V. So y equal absolute value of x looks like this. And what I'm going to do to make this a little easier to see is I'm going to take these points and actually write the new point of the transformed graph down before I graph it. So let's start with 0, 0. Now we need to, since a is 1/2, we need to take our x coordinate and divide by 1/2, or multiply by the reciprocal of 1/2, which is 2. So I'm going to multiply every x value by 2, and when I take 0 times 2, I still get 0. So the point 0, 0 is transformed to 0, 0, so it stays where it's at. The point 1, 1 is going to go to, now again I'm multiplying by the reciprocal of 1/2, so I'm multiplying by 2, multiply by 2, so I have the point 2, 1. The point 2, 2 is going to go to 4, 2. And let's go ahead and do negative 1, 1. Negative 1, 1 is going to go to Then we're going to multiply by 2, so negative 2, 1, negative 2, 2, going to go to, multiplying by 2 gives me negative 4, 2. So let's go ahead and graph these new points and then ask ourselves if that looks correct. 0, 0 is still going to be here. 2, 1, 4, 2, negative 2, 1, and negative 4, 2. So our new graph looks like it's up 1 over 2. So this is the graph of y equals the absolute value of 1/2 x. Now if we ask ourselves, does this look right? We can simplify this expression. Y equals 1/2 x inside the absolute value is the same as y equals the absolute value of 1/2 times the absolute value of x. And we know that the absolute value of 1/2 is 1/2. So this is the same as 1/2 times the absolute value of x. Now we know from our previous video that this will take every y value and multiply by 1/2. So in each of these points, the y value, for example here, the y value is 1. So if we half that, we have 1/2. The y value is 2, half of that is 1. So this does check. I mean, it makes sense that our transformation would look like this. Let's try another one. Right, in this example, we're asked to graph y equals the square root of 2/3 x. Our basic graph is y equals square root of x. And so let me put that in here with the dotted line. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and square root of 16 is 4. So our basic graph looks like this. Now from our rule, whenever we have our a multiplied inside the function, then we need to divide x values. This means divide x values by 2/3 or multiply by the reciprocal, which is 3/2 or 1/2. So I'm going to do this because it's a little bit nicer mathematically. So again, let me write my ordered pairs. 0, 0. When I multiply the x value by 1.5, I still have 0, 0. The point 1, 1. When I multiply the x value by 1.5, I get 1.5, 1. On my next one, the x is 4, and the y is 2. When I multiply the x coordinate by 1.5, I get 6. And the next point, 9, 3. When I multiply the x coordinate by 1.5, I get 13.5, 3. So let's plot these points. 0, 0, 1.5, 1, 6, 2, and 13.5, 3. So my transformed graph looks like this.